Hello students. In the earlier class, we have completed block 1. Now we are moving to the block 2 where we discuss about the manufacturing process, planning and the tools that are involving in the manufacturing of any organization. And with regard to this, even we discuss what are the tools that are available. So in this block, when we talk about manufacturing process and planning tools, in that we talk about CAD, CAM, that is computer aided design, and also the use of technology in the manufacturing process. That's what we'll try to understand in the block 2. And here we have 4 units in the block 2. They are information management tools, which includes product and process tools and barcode system. Means what are the different types of barcode that are available. If you go to any store, we find they scan the product and give you. But scanning that product, the barcode which available on that particular product, it is not similar on every product. It differs from one product to the other product. So what are the different barcodes that are available, that we'll try to understand. And the next part we try to have a clear clarity about the material requirement planning and manufacturing resource planning. That is, two are MRPs. One is about material requirement and the other one is manufacturing resource. And just-in-time manufacturing and lean manufacturing process and applications. So when we are talking about this, all the topics, we are trying to explore how the technology is involving in the manufacturing of products. What is the advancement of technology? Is it the same when the industrial revolution has taken place or any other changes that has been taking place? Now we can witness n number of new technology that is entering into the manufacturing process. So now let's understand what are the information management tools, in which we try to understand about product process tools and barcode system. So here information management tools and barcode product and process tools and barcode system. Here they talk about the product and process design tools like CAD, CAM, CAP, and group technology. You can just look at this. This is the most product process tools that are used in the manufacturing or the information management tools and the barcode systems. The more concentration would be on product design and process design. So when we talk about this, actually manufacturing, any industry you take, from the day of or the from the since industrial revolution to the current global and the competitive age, from the industrial revolution to the current global competitive age, it's very important to the any manufacturing concern to update themselves or to use or to make them updated as per the requirement of the customer needs. And it's possible only when we follow or when we implement the present current technology in that. And whenever we are using this technology and that application into the process of production will make it to lead or achieve world-class manufacturing processing. So under this, the world-class manufacturing was introduced in the automobile, electronic and steel industry especially. World-class manufacturing was introduced in the automobile, electronic, and steel industry. And the process what was driven approach where various techniques and philosophy are used in one combination or the other. In one combination or the other. Currently, whenever customer making any purchase is not only interested in a product, but also to a large extent, extra services provided under the purchase contract. So there are many policies depending on the different organizations, how they are providing the product to the customer, what are their requirements. So here the customer is given the first preference in providing the product requirements. So one can say that learning organizations can be successful in competitive market. Why? Because they always learn. It's not applicable only to the organization, even for an individual also. The learning makes us to improve or be ahead than others. Similarly, whichever the market is learning organization, which is learning in the course of production of manufacturing any product, because they will be morely most their focus is on the development of employees qualification, process development, and continuous management model development, and changes in business models. These are all the examples of world class manufacturing. And this concept was introduced by organizations using the best production systems in the world itself. And here the main aim is to achieve global competitiveness by adhering to the following principles: no waste, no stock, no future failure. So the main principle is on no wastage, no stock, and no failure. So this will make them that no defect. These are improvement of applied processes which increases the productivity and also improves the security. And in turn this makes to reduce the cost reduction takes place. So because of this what happens, all the time they are looking after the employee development, and also they are looking about the requirement of the product. So what happens is this will make even the employee also to work all the time attentively. Why? Because when it is under the observation or in the process of observation, and every time their performance is being checked, in that case their concentration is not only on the production but always they also try to learn and update or upgrade themselves. So this is how normally the world class manufacturing where they concentrate. So here when we talk, because here we are talking about information technology for the management, how it's useful to the management. So the main concept when we talk about the concept of information technology, where many managers, business managers are facing several challenges like carrying out the company operations. Why? Because among them there is a creating information sharing systems. How does shipping get the order from customer service? How does operation management share forecasting models? So this all information the management requires whenever they want to take any decision. So to know all this, the one fundamental component in today's business environment is information technology. Only the technology is the solution for the management to know details of all these things. For example, the organization is in the manufacturing unit and they want to know how they are ordering, because the management does not take, they will be having some other person, so all the time they may available or may not available. But if we have some information technology, some source where through information technology where we can retrieve this all data, where we can retrieve all this data, in that case what happens, this will be much more useful for the organization, because here information technology plays a key role in the management, because if they have ready data available with the management, they can take immediate business decisions. So here what happens, managers must control the streamline the flow of information throughout an organization. And today's business are they all are multidimensional, and customer orders affect fulfillment, accounting, personnel, inventory, sales, and all other operational functions. And also supplier shipments require input from receiving functions, and management provides forecast and planning models for other departments also to follow this. So without the information technology nowadays, it's highly impossible for the management to take the spontaneous and the immediate decisions. Now, what is the need to manage information? Let us understand that. So here need to manage information means the tremendous growth and the heterogeneous collections of digital information may depend on different types of information management tools that try to preserve, organize, and access information needed to carry out their professional tasks. And the points which give the need to manage information are to save time, because if the data is available at some particular database with the help of technology, then it will be very useful for the management, because this will save the time. And also if the information is stored, this will preserve the information, and in turn it will even maintain data integration integrity to understand and use information in future. So what are the key technologies that are used in management for the purpose of knowing the information? In that we have, these are the different sources that are available to us, and in which the first one is invention of mainframe computers. So this was the first stage where the data was stored and which was used for the purpose of mainframe computers. The next one is invention of mini computer. Then comes word processor, personal computer, development of computer network and linking of PCs and workstations to a central machine, and development of LAN, linking individual groups of PCs together, often with a mini computer as a shared repository, development of WAN via satellite or landline, linking users together with a linking users in one network with information stored on a remote machine, or with users on that network. Even we have a creation of optical storage device capable of mass storage text and document images. The next comes creation of document scanning technology or electromicrofilm. So these are the different technologies that are used for the data information or the information to be stored in the organization for the purpose of management which want to take the immediate decisions. And if you look at here, now let's understand how the info, what are the other info, these are the key technologies that are being used. And apart from this, what are the information management tools that are available? As it was said from the point one, that is CAD, computer aided design, and the other one is K, that is CAE, computer aided engineering, and CAP, computer aided process planning. And the next one is product data management and the group technology. So these are the different management tools that are available for the management to take the decisions and spontaneous decisions where they can store the information. And this is how means these are tools used to know the product design or to manipulate the data on products and processes. So here let's look, even we have, apart from that, we have lean production tools, and under which the most one is Japanese manufacturing techniques, that is just in time, or such as the famous Kanban technique, or statistical quality control, barcoding systems, decision support, execution of business tools. So this all comes under for the information management tools. And next one is product and process design tools. So to we think the how the product design is made is with the help of CAD, that is computer aided design. So here when you talk about these two tools, designing tools, actually here we have three designing tools, that is computer aided design, computer aided engineering, and product data management. In this, we are creating virtual models. We are creating virtual models with minimum effort and menial task of 63 drafting. And in the initial years, the CAD was the primary, viewed as the primary advantage of computer application in design. But today, we have n number of models that are available for the product design, and even we have finite element analysis, which are helpful for the manufacturing concern in the process of production and how to design the product. So now let's understand the CAD and CAM. CAD or CAM means computer design or computer manufacturing. So this application, we see, we hear n number of students learning the course of CAD. Yes, they involve using the application of computer to the manufacture of engineering components. How? From drawing to the production phase to the machine, then comes assembly shops, quality control department, and to warehouses. I mean, this is a sequence how means with the help of computers or with the help of computer technology, we are designing the product, how the product should be there. What is the first stage? What is the second stage? How means in first stage, what happens to the product? Next stage, what is its phase? Till it reaches the warehouse, all the data. So that is done with the help of CAD. So the technology of CAD or CAM represents an efficient and accurate, consistent method for manufacturing a high quality products. This method is used for producing a high quality products. And then in this, what is the role of computers in manufacturing? Because everything is done in the manufacturing organization or the manufacturing unit or the factory place. So what is the use of these computers in manufacturing means? The use of computers had a positive impact on manufacturing engineering in many ways. Like why we are using engineering? Because here we apply the profession in which knowledge of mathematical, natural sciences, which are gained by study or experience or practice. For what purpose? For the efficient use of materials and its forces of nature. So here the term engineer denotes a person who has received professional training in pure and applied sciences. And the first and biggest positive impact on engineering has been the use of numerical control machines. So these were first introduced in 1970s, which used to replace in conjunction with some existing manufacturing process. So this is how they used. So the role is classified into two groups. That is CNC computer numerical control machines were introduced earlier, and these were used like they would have to place a drill in the drill chuck, the secured in the spindle in the drill. Means these all are how machine they used to. Say example they given us. So here they are classified into two groups. One is computer monitoring and control of all the manufacturing process. So here manufacturing support appliances which deal with the preparations of. So what we are doing, we are using the manufacturing support applications, actual manufacturing and post manufacturing. And when you look at here in the first category, the computer is directly interfaced with the manufacturing process or monitoring control tools. For example, in any chemical process industry, there are n number of process parameters which has to be monitored, which has to be monitored. And in the second category, all the support functions which are included in the successful completion of manufacturing operations. For example, if you look at here, CAD, which use computers to develop geometric models. What they do? They use geometric models in 3D form. So what they are doing? They are using geometric models in 3D form. Next, CAE. Here they are using computers to support basic error checking. So their work is to check whether there is any error or not. They will analyze if it is there and they try to optimize it. And what is CAM? Use of computers to generate software. It generates a software to develop the computer CNC, we said na, computer numerical control part, programs for machining and other process. So these are, if you talk about CAD, CAD is about looking about 3D form of product design, geometric models. And CAE is talking about checking the errors, analyzing and optimizing. And CAM is talking about the CNC program for machining and other process operations. Next, advantages of CAD. It is very fast, accurate than conventional methods, and under it is possible to manage various dimensions and attributes for drawing elements. And also modification of model is very easy, which makes the designer task for improving a given product and take care of any future requirement. And professional CAD packages provide 3D visualization, which provides capabilities and the designer where means these are the advantages where the CAD is more applicable and useful to the manufacturing organization. Next one is CAP, computer aided process planning. That CAD was used only to provide for designing geometric models, and CAP is used computer technology for designing physical products. It is a software. This is a physical products, and it goes along with the things like CAD and CAM. It works with both the things. But computer process plan, that is CAP, focuses on only on industrial process, especially on industrial process, and it is a link between the engineering and manufacturing process. And process planning can be defined as an act of preparing processing documentation for the manufacturing of a piece, part, or any assembling the any parts of the machine. And if process planning was done by using a computer, it is called any product or any product, if you're processing or if you're producing with the help of computer, we call it as computer aided process planning. And under this, it systematically works, it which makes consistent process plans, it reduces the cost, and also it makes less skilled process planners to be employed. We don't require much employees because it's everything is done by the machines. Means if you see if you see any national geographical channel where we can say a big number of machines which will work automatically, they'll select the they'll do all the activities of the production where very less number of skilled employee or skilled labor we require it. And this will in turn increases the productivity of process planners, and also manufacturing cost, its lead time and work standards. This all can be interfaced with the help of cap system. So why computed process planning? Because it's understand the interaction between the part, manufacturing quality and cost. The same features are related as why it is required, and it increases the productivity, it decreases the cost of production. And what the different parts of CAP are: GCAP, VCAP, and RCAP. GCAP means Generative Computer Aided Process Planning, and VCAP means Variant Computer Aided Process Planning, and RCAP means Retrieval Computer Aided Process Planning. So these are the different parts of CAP. So which is detailed from scratch, like the given inputs. So group technology, this is an approach for organizing or manufacturing, and which can be applied in any industry like machining, welding, foundry, presswork, forging, or plastic molding, where small batch variety production is used. There the group technology used. And here the main basic approach for all the aspects of manufacturing is from design through estimating the planning to production to be rationalized. And group technology layout. And here in the one of the most popular types of hybrid layouts is group technology or cell layouts. And here it has the advantage of bringing the efficiencies of the product layout to the process layout environment. And just look at this picture will depict everything to us. So just this is how the group technology means, where we require small batch type of production, saying that there it will be used. And if you can just look at here on x-axis, they said output or product variety, and on y-axis we have production and operations volume, and in this we have mass production type, where means it's telling us this is job shop type, batch type, and mass production. So your group technology is applicable to the only to the batch type. You can just look at here. So job shop production system, we have group technology layout, batch production system, and mass production system. And your production operations or or operation flexibility, it may increase or it may decrease. Uses of group technology. So this is used where there are numerous parts in any assembly that will be used, and they are like nuts, bolts, screws, keys, washers. These are standard and proprietary parts. Like similar parts like shafts, gears, bearing, lever, and product specific parts like big gearbox, bed, saddle, etc. So these are the group technology, where group technology used very with small batch of production. Next is barcode systems. And in barcode system, it's a technique for instantaneous acquisition of any event data into a computerized system. and data is stored of a series of bars and white spaces based on standards such as universal product code, that is called UPC, and its key components of a full-fledged barcoding system are. And in this we have the medium, that is an adhesive label or a card or a document on which barcode is symbol is printed. And next are printers. We have typically inkjet or laser printers are used, and scanners. These are optical devices, mostly handheld, consisting of an emitter or a detector or an optical lens. They extract the barcode data from a printed barcode symbol. Readers take data, means here data is reconstructed by scanners, and this will convert into some usable forms such as ASCII text. So that will decide what is barcode, what is actually it consists of. Barcode is nothing but a pattern of bars, spaces, which will vary with which will represent the various digits, letters, or punctuations. And this will store that whenever you just scan on any barcode, if you just observe it whenever you visit any of these stores, as soon as they scan it, they get all the details about that particular product. Its color, its rate, when it was manufactured, where it was manufactured, what is the date of its manufacturing, means what's the validity, who is the manufacturer, that all details will
So if you just look at here, we have the what they have explained us what is barcode and what are the different types of barcode that are available here. So barcodes are nothing but a bars or spaces of varying width that represent digits and or letters or the punctuations or symbols. Means whenever you scan, if you go to any store and if you purchase any product or apparel in any of the stores, when they scan it, they get the details of that particular product, about the price, the cost, what is the date, when till when it has to be stored, what is its expiry date. That all in detail they cut. It will be displayed on the system. So this means here, barcode is predefined format of dark bars and white spaces. Barcode is nothing but the lines which will be formed in the form of like black color and white spaces, which will represent. And when it has been scanned, we'll get the means the bars which are there, the lines forms that are in the form of binary system or binary code, where ones and the language is designed in ones and zeros. So here how barcode work, if you look at here, the width of the black bars usually represent the number of just look at here. So this is how barcode components, so this is how barcode works actually. It's a lines which are with special patterns that are available. So how barcode works, because they are usually represent the numbers 0 and 1, and those bars signifies between 0 and 9, which are connected to the scanner and has all the information on what item is associated, what is its unique combination of bars and spaces, and it won't be similar for each product. It changes from the product to product. The barcode changes, and here and may add or they multiply or divide those numbers to identify the correct product, which is visible on the screen. And in warehouse, the barcode might encode an item size, color, and other attributes as well as its location. So the company has a detailed view of current inventory and can quickly fulfill the product's inventory counts. So you can just look at your barcode components. It's a designed a precise or uniform way, so scanner can read them and transmit the encoded data to a computer. So, using various components, a barcode may also reveal the country of origin. Means, for example, if it is a from foreign product, it is. So, it will even reveal the which country the product is been produced, where it has been, or its origin, and its product category, and also the manufacturer who has manufactured that. So, if you can just look at here, there's a diagram which depicts the different elements of UPC barcode, followed by an explanation. You can just look at your elements of barcode. It's a quiet zone, barcode symbol, and quiet zone. You can just look at here. So the start one is a character, means it will be any alphabet. And the next three numbers are data message. And the next one is check digit. And the last one is again stop character, start character and stop character. In the middle, we'll have data message and also check digit. So you can just look at here. Manufacturer codes and product code identifiers between the number and check digits. And if you look at here, the first one is number system digit, and the next one is manufacturer code, product code, or check digit. And we said quiet design. Quiet design means it's an empty space, white space on the edges. If you can just look at here, the white space which is available now here, the last right side as well as the left side. The white space is called, it's an empty space which is called as quiet zone and is necessary for the scanner to read the label. And here we have number system where the first digit represents the product category on UPC codes. For example, retail product often start with 0 or 1. So pharmaceuticals with 0 and coupons with 5. Similarly, manufacturer code, the first group of characters after the initial number. Usually, that will be the manufacturer, GSI, a global standards organization which will regulates UPCs, assigns each manufacturer unique code. Next is product code, means the next set of characters which will identify the that specific product which are created by the manufacturer. Next we have is check digit, and in this check digit it will confirm the accuracy of the data that tied to that barcode and flags any potential errors. So the numbers whichever are that are available in that barcode, they each one will signify and give the data about that particular product. Is what are the benefits of barcode? It gives accuracy, real-time data, reduced training, and on to inventory control and low cost. Next, use of barcode scanners. So these are the barcode scanners. If you just look at your handheld linear scanners, they are fixed and they can be held in the hand. They're vertical dark bars separated by light spaces. Just look at here, they'll scan which are connected to the system, and in turn that will scan it. You can see here we have different types of barcodes. That is just you can look at here. The above one is like lines, and these are different things with squares, boxes at the end ends, and different shape it is, different structure. So types of barcode system. The first one is one dimensional or barcode 1D barcode types. You can just look at here. These are systematically represent data by varying widths and spacing of parallel lines, and it includes the most traditional as well as well organized barcode types like UPC and EN codes. Commonly they are linear barcodes, and the length of one dimensional barcode is directly tied to how much information it holds. Next is matrix 2. This is 2D barcodes which can store additional information like quantity, images, website URLs. That all it can be done in this matrix 2D barcodes. Only the difference in between 1D and 3D is 1D they have horizontal lines or vertical lines, whereas 2D versions can have both along with other shapes and patterns also. And 2D bars holds more than 2000 characters compared with 80 characters, with means in 1D they can store only 80 characters, whereas in 2D they can store up to as many as 2000 characters. Next is 9 component common products that are UPC, Universal Product Code, which you can find it. Next is EN, this is European Article Number Code, Code 39. The different barcodes means if you can just look at here, code 39 is used in automotive and defensive, and code 128 is used in logistics, transportation, which are high density codes they are, and they are towards non-POS products like serial shipping container, they'll use it. ITF interleaved 2 of 5, and it's used in packaging. And Coda bar, this is no longer the leading type of barcode actually. One of the earlier barcode format it is, and Coda bar codes may include any number of letters like A to D, it may be anything. Next is QR code, which is normally nowadays it's used in everywhere because there's a newer version of smartphones which can read with barcodes. And PDF 417. This also linear and consists of anywhere from 3 to 90 rows. It's a basic linear barcode. Data matrix, it's a 2D barcode against a data matrix. So this is all about the barcodes and the product process planning. The next topic is material requirement planning and manufacturing resource planning. So in this material requirement planning is nothing but the calculating the materials and components that are needed to manufacture a product. And it consists of 3 primary steps like taking inventory of the material, components on the other hand, and identifying which additional ones are needed, and then scheduling as per that production. And in this, we'll try to understand what is MRP1 and MRP2, because we have two MRPs now, that is manufacturing requirement planning and manufacturing resource planning and material requirement planning. And here we are talking about material requirement planning, which have become the most effective and widely used inventory control systems, and that is across the world. And many operation managers have found the vast knowledge that MRP systems is absolutely and remaining with regard to the MRP, we'll discuss in the next session. Thank you.